Hello, I'm Yoon from Hanyang University. Today I'll present our EMNLP2025 accepted paper, Beyond Task-Oriented and Chitchat Dialogues, Proactive and Transition-Aware Conversational Agents. This work aims to build conversational agents that can handle both goal-driven and open-ended dialogues in a single framework. Let's start with the motivation. Traditionally, dialogue systems fall into two worlds. Task-oriented ones are goal-driven and efficient, but not good at keeping the talk going. Chit-chat models are the opposite. Open-ended and engaging, but not goal-focused. In real life, though, users naturally mix both. You might book a train, chat about the weather, then go back to the booking. Our goal is simple: to build a single system that moves smoothly between these two modes. Existing datasets don't support this. MultiWAS is pure TOD. Fuse Chat allows only one switch. Interfere Chat forces a single chit-chat turn with no recovery. In contrast, Tact supports multiple transitions, 2 or more per dialogue, and includes recoverable flows and balanced user-agent switches. This makes it the first dataset where agents can actually return to the task after digressions. Here's an example. When the user starts chatting about train scenery, most models get stuck or switch back abruptly. The tact-trained agent responds naturally, acknowledges the comment, then continues the booking. This is our key idea: turning agents from reactive responders into proactive flow managers that understand and control mode transitions. Tact combines MultiWAS 2.2 and Slurp and expands them into 2 main flow types. The first is TCT, Task to Chat to Task. It starts from a long task-oriented dialogue, adds a short chit-chat in the middle, and lets the agent smoothly return to the task. This simulates off-topic turns where users briefly digress and the agent naturally resumes, like returning to a train booking after small talk. The second type is the CTC flow, Chat to Task to Chat. Here, a light conversation happens before and after a short task. This pattern reflects more casual interactions. For example, a user chatting about weekend plans, briefly setting an alarm, then continuing small talk. Together, TCT and CTC flows allow our dataset to cover both user-driven and agent-driven transitions, resulting in smoother and more human-like dialogue continuity. To ensure quality, we validated every dialogue using 3 human-aligned criteria: intent accuracy, transition quality, and dialogue naturalness. These check whether the annotated intent truly matches the user's goal, whether transitions are logically consistent, and whether the conversation feels fluent and natural overall. In short, we didn't just generate dialogues, we verified that each transition makes sense to a real user. We built a hybrid validation pipeline combining human criteria with LLM reasoning. Using GPT-4o as an evaluator, the model summarizes the task, applies evaluation criteria, and produces step-by-step reasoning to justify its judgment. Compared with previous methods like geval or Active Critic, our approach is the only one that integrates both human-aligned standards and automatic reasoning, making validation scalable yet interpretable. Finally, Tact dataset consists of nearly 10,000 dialogues built from MultiWAS and Slurp. It includes over a dozen unique flow types, recoverable structures that return to suspended tasks, and balanced initiators, meaning both user and agent-driven switches. These properties enable models trained on Tact to learn multi-turn, recoverable transitions, achieving richer flow diversity and smoother context continuity than any previous dataset. We compare modeling paradigms for handling task chit-chat transitions. First, ICL, zero or few shot prompting without training. Second, SFT, a supervised fine-tuning baseline trained on full datasets. Third, pipeline, separates mode control and response generation for modularity. Each approach tests how well agents can handle both TOD and chit-chat transitions. For evaluation, we measure both what the agent does and how it talks. TOD metrics cover mode selection, intent detection, and joint accuracy, checking if the model identifies the right mode and task. Chitchat metrics follow the SSI framework: sensibleness, specificity, and interestingness, plus our new measure, transition naturalness, which checks how smooth mode changes are. Beyond that, we propose flow-aware metrics: switch and recovery. Switch measures whether the agent initiates a mode change, and recovery checks if it returns to the previous task naturally. In short, can the agent switch and come back smoothly? First, task performance. The TACT-trained model achieves the strongest TOD results and shows the best generalization across datasets, meaning transition-rich training also improves core task robustness. Only the TACT model records non-zero switch and recovery scores, proving it can proactively move between modes and resume tasks. Other models show zero recoverable flow. When tested across MultiWAS, Fuse Chat, and Interfere Chat, the TACT-trained model maintains consistent performance. This shows that transition-aware supervision helps models stay stable even under different dataset formulations. And comparing methods. ICL transitions frequently but unstable. Low control. SFT has the best TOD accuracy but weak chit-chat quality. Pipeline is stable yet rigid, lacking flexibility. This leads to our next question. How can we improve the naturalness of chat responses? To address that, we apply Direct Preference Optimization DPO. We build 3009 preference pairs, comparing SFT outputs with GPT-4o Mini and letting Gemini 2.5 Pro decide which response is more natural. This aligns the model with human-like tone and coherent mode recovery, combining TOD precision with chit-chat fluency. Now let's see what happens after DPO alignment. DPO maintains strong TOD accuracy, around 96%, but improves response quality dramatically. It raises the chit-chat win rate by 17 points, up to 40.9%, and achieves the highest switch and recovery success, over 1 per dialogue. Simply put, DPO achieves the best overall dialogue level accuracy with the strongest flow awareness. When judged by Gemini 2.5 Pro, DPO consistently outperforms SFT and Pipeline in all qualitative metrics: sensibleness, specificity, interestingness, and transition naturalness. It gains around 20 points in interestingness and about 22 points in transition smoothness. Even an LLM can tell. DPO makes the conversation flow naturally. To verify this beyond automation, we ran a human evaluation with 10 annotators on 77 sampled dialogues using the same SSI and transition naturalness criteria. This complements LLM judging with genuine human preference validation. Humans clearly favor DPO. It wins over 70% of pairwise comparisons, being rated as the most fluent, engaging, and context-sensitive model. For example, while the baseline jumps back to the task abruptly, DPO adds a natural acknowledgement before resuming, capturing the balance between task precision and conversational warmth. Our ablation shows that recovery does not mean repetition. Only 34% of recoveries return to the same intent, while 66% start a new but related one, showing contextual flexibility rather than rote memorization. The model performs strongest on TCT flows, weaker on CTC, where fewer agent-initiated cases appear. This suggests we need balanced supervision for ambiguous transitions. To wrap up, first, a transition-aware dataset. TACT enables recoverable, multi-turn dialogues. Second, flow-aware metrics. Switch and recovery help us measure adaptability. Third, a preference-aligned model. DPO improves smoothness and engagement. And finally, open source. All data and validation templates are available on GitHub. Together, these make TACT a step toward proactive, human-like conversational agents. Thank you for listening. I'd be glad to discuss more or answer any questions.